Robert, how are you?
I'm good.
Good,
I
good. I have invited a friend who I hope will show up. Uh,
no,
he's he's been helping me with Soil Smart. And he's an architect. Well, I've wanted you to meet him, and I think you have. I can't remember whether we did it or whether it's just in my mind that I'd like to have that happen. Carl Welty, he's a architect.
yeah, we've talked about him. I don't think I have met him.
Okay. Hi, Mark. Yeah. Oh, we'll have a full house today, so I hope Carl shows up. It would be really great. So, Mark, I've invited Carl Welty. I think you know him from GRC. He may show up today. I'm also a little impatient because I'm in the middle of a water summit, which is really fantastic. And the next session will start in a half hour. So I may transfer the hosting to somebody, and there's Carl and abscond.
I've been working outside this morning in the 95-degree heat, and I may only have a half hour in me. As I get older, I meet the stamina to
You know that.
just the way
Yep.
it is. I'm repairing a fence line and takes a certain amount of time.
Yep. Yep. And oomph.
30
Yeah.
minutes works well for me too.
Yeah. And Zach Weiss was on this morning, and I don't know if you know who he is, but he's in Montana, and his focus is on landscape redesign. He's been doing it for 12 years worldwide. Um, and it's just wonderful. I was telling Carl that the big thing that I have gotten out of this summit, which is just really juicy for me, is to really start talking openly about regenerating climate, because that's really what we're doing. If you understand the water cycle, which is what the bionic pump is talking about, you are regenerating climate. So we don't have to adapt to it. We have to regenerate it and put it back where it should be. And we can do that by small people and at scale. And the more people who do it and the bigger the scale we get, then the more profound the impacts will be. But there's been lots and lots of people doing this. I was so proud of myself being on the cutting edge of things and stuff. And now I'm discovering people have been doing this for years and years and years. And I'm not on the edge of anything. But it is just amazing the stuff that they are doing in other parts of the world where people don't fight what they can see with their eyes the way they do here in the West. And it's just been delightful to see before and afters of all these people who are doing massive, massive things, just really huge. India, there's several projects in India, actually. There's an organization in India that has been getting villages to compete with each other to build water holding structures and redo their land. So they make it a competition and are just doing it at scale. And these are places where people use shovels, They're not using large equipment at all. They just get lots and lots of people to dig. And are having incredible results by being able to keep the water they get and to see it recharge the ground and regenerate the landscape. So it changes the climate, that's the whole thing is connected. So being to see and to talk about our ability to regenerate the climate is a huge factor, I think, in addressing climate change. The whole carbon fossil fuel issue is just it's a dead end. It is a non-productive and actually not scientifically accurate way of addressing climate change. It's a very teeny tiny piece of the whole thing and not anything that we have any control over. But the water cycle is something we do have control over and can deal with, and it's not talked about at all. So real exciting stuff, I think. Yeah, and Zach even uses the word bionic pump. I was so thrilled. People are really avoiding it in a lot of ways. I don't understand why, but they are talking about new water cycle and this small water cycle, and but none of them really speak to it in the way that the biotic pump does. And it really is a full system cycle. That's what I love about it. That most of the water cycle stuff is not full system because it leaves out dirt. It's all on the surface of the planet, and it's not on the surface of the planet. It's only by sinking that the pump has the ability to pull water out. So you have to have water in the soil first. That has to be an inventory. And those are things that we can all do stuff about. It's just so exciting to me. It's so exciting. And there's a lovely, and I'm trying to get this, and if I can get this, I will share it. Let's see what I can share. And you can tell me when you try this if it works for you. I had somebody else try it and it didn't work for her. Or she said it didn't. I just don't know. But they did an animated video. It's 12 minutes long. And it has to do with the bionic pump. And it's just a lovely explanation of the pump and how it works and how it changes climate. And I thought I put it in here. Let's see, just a minute. It's hard to do two things at once. And I've got a new class that we'll be doing on rethinking climate change. Did we get it all wrong? So this is the only link I've been able to get to this video at this point in time. Oh, that's not right. Oh, no. Okay. Okay, so let me put it in the chat here. And it's just a little, oh, there's Ani. So see if this works for you, if you can find the video there. It's animated. And it gets into cities. So I was real excited about the things that cities can do. Good morning, Ani. Oh, she's probably not here yet.
No, I am here.
Oh, okay. Okay. So I was just telling people I'm in a summit and the next piece starts at 11. So I can make somebody the host and you guys can continue if you would like. But I'm going to want to go back to this. It's really, really exciting for me. It's just validating and everything that I've been working on and the whole point of Soil Smart and all that kind of stuff. So it's just a thrill to see other people doing the same kind of thing.
Well,
and
good.
Carl Welty is here, whom I would like to introduce to both Ani and Robert. Mark knows him from GRC. Carl's an architect, as is Robert, sort of. Robert's a builder, but I think he does a little architecture in that process. And Carl's focus is on working with nature, so passive design that really makes the best use of how nature puts the site and that kind of thing. And he's been doing some work around different ways of building. I think I mentioned to you briefly once, because Carl's really interested in steel as opposed to wood for a number of reasons. Maybe we can get him to talk a little bit about that.
Yeah, I'd like to hear that because steel is not organic.
When we start now. Here. So neither is the wood we build with. So like this, my searching for something else other than wood started in 2000, working on a couple of projects. And I realized the quality of the lumber we have today is so bad that it it's not going to last as long. It burns faster. It this causes lots and lots of problems within the construction. And I could bore you with the details, but recently I've become very clear that the like in my industry, the architecture, the green industry is kind of bought this hook, line, and sinker and perpetuates it. But we think of the wood that we buy, do we build with, as coming from the forest. It does not come from the forest. It comes from a single crop plantation. It's the concerns we have about monocropping, et cetera, bad for the earth, bad for the larger ecological systems. This is exactly where we get our lumber from. It's not from a forest. And like like any other food product, that the nutrition's not there. From food products from monocropping, the food, the quality's not there, the nutrition's not there. It depletes the soil. So all of this stuff happens with our plantation grown trees. So to start with, and then because the wood is so degraded in quality compared to 100 years ago, most like, and Mark, you probably Robert, you could confirm this, but most even in simple construction, anything larger than a 4x6 is what's called a manufactured lumber. It's all glued together with really toxic glues that, when burned, releases cyanide gas that kills people in fires. Do you want me to go on?
How do you recycle steel?
Well, steel is really easy to recycle. And I mean, if I get your email address, I'm happy to send you some PowerPoints. So in my quest to understand how to build better, and I have looked at lots of different systems and used a few, but I met a gentleman actually in 2011 who, in Southern California, who started building with light gauge steel in '96 when there was a bit of a movement to do this, and he sort of kept working at it. And so he's really has developed an ingenious process for delivering the steel to the site. It's all pre-cut like an erector set. We're all old enough to know what an erector set is.
Called what?
It's like an erector set. So the steel that we're talking about is light gauge. It's not big heavy steel like I-beams, but most of the steel that the manufacturers who make this stuff, but probably at least 75% of the steel is recycled steel. But across the board, steel is infinitely more, is easier to recycle than wood. I have a few, and I'll put my email address. So one of the things that's really brilliant about what he does is, because the way the steel is manufactured, it's all computer controlled. And so like the comparison is like with wood, if you're building something and you need 320 studs that are 8'3" and 1/8 inch long, you buy 320 10-foot studs and you have somebody out in the field cutting each one and measuring and cutting each one. But with steel, if you need 320 of these studs that are 8'3" and 1/8 inch long, you just tell the computer to cut them exactly like that. So there's no waste. So it has reduced the amount of waste. And so just on the waste part of it, and I use this as a reference by a 3,000 square foot house. The waste that this process creates on a 3,000 square foot house is less than a cubic yard, and it's 100% easily recyclable. Compared to the conventional lumber construction, for a 3,000 square foot house, the amount of waste, the lumber waste, is between 13 and 21 cubic yards. And that wood it's always shipped to a Class A dump, Class 1 dump. That's so the recycling of wood is we haven't figured that out yet. So
by my understanding of recycling is something that, and I'm not educated in this, okay, but is that it's not only that it can be used for different purposes, but that it biodegrades and becomes part of nature, which knows how to do whatever it needs to do. It might not make any sense.
well, those are really good questions, but so one of the reasons why I like steel is it does not biodegrade. And so one of the things I've noticed, so like we're often you might be familiar with a beautiful old craftsman home or a house built in the 1920s. The lumber is really beautiful. You can look at there's big beams that are like 8 by 12, and there's not a knot in them. And the wood is very stable and strong. Stable by it doesn't expand and contract. Because the wood that we grow today it grows so fast, it expands and contracts, and the termites like to eat. The termites like to eat it. It doesn't last as long, and so
Where's that picture? You have a picture?
I'll attach it.
Yeah, he's got a
Um,
wonderful picture of old wood and new wood, and you can see the difference in the density and how it's grown.
I see Robert nodding his head to a lot of what you're saying, and I wonder if Robert could shed some light on what you're saying to help us understand better what you're saying.
I just
Yeah,
put I just put a picture. This is a really powerful picture that shows a 2x4 a stud from 2018 versus 1918.
Yeah, I mean, I started building houses in the early 70s, actually late 60s. And we could still get 4x14s, even 4x16 solid wood. Definitely 6x10s. Right up until about 1980, because this was in Oregon. But there wasn't appreciation for that. Many of the old growth forests were being lumbered, definitely. And from my understanding, most of that wood was being shipped to Japan.
At the time, yeah.
At that time, I don't know what's
I mean, we have in America, California, we have very little old forest left, and to the point about the large ecological systems or cycles, old forests, natural forests, work. They are biotic pumps. They're working. They help the water cycle. So one of the ecological downsides or problems with the single cropped lumber industry not forest, tree farms, is that the soil doesn't there's no effort to get the soil working like a natural forest. And so this issue is kind of the larger ecological downside of the way we grow lumber now.
And so just another part of that, Carl, is that there wasn't a consumer base that was at all interested. Particularly, I spent the 70s totally wrapped up in working with passive solar housing. And that would require, there weren't servo motors attached to everything then. So you had to adjust it yourself. You had to close the blinds. You had to pull down the insulating blanket in front of your window. And people just didn't want that. I mean, they would tell me to my face, they said, "That's really nice, but I'm not doing that."
The servo motors, I mean, there's a ways to do that now more automatically.
Right, there is.
That's actually an interesting point. But in as an architect, my take is that architects um, have turned away from it. I mean, it also lost sort of interest because of oil got really cheap in the 80s and Ronald Reagan. But now, um, I mean, I was exposed to passive solar because I had a professor in college who is now retired, but was really a national leader in that realm. And I mean, he and a few other people were smart enough to know that oil is bad and that we need to take better care of our planet. And those sort of questions were also lost in the 80s and 90s and kind of rediscovered in the 2000s. I actually wanted to piggyback on something that Kathryn said, which is like you know, we lose the first principles. We lose sight of the first principles, and so in the green architecture world, you know, they're not interested in. There is very little interest in passive solar or ancient systems that work without anything, because we're always trying to reinvent something, a new phrase, a new technology. And for me, it's the what's most successful is working with first principles. And in terms of building, the result is these buildings that incorporate passive solar, you know, they're 50 to 80% better than normal versus the green design that we're supposed to be like LEED certified buildings. The best they get is 30%, and most of them are between 0 and 12% better than normal. And the better than normal, the energy side is, to me, buildings. So the energy that takes to provide thermal comfort into buildings is probably the largest part of the greenhouse gas pie of everything. And so if buildings are about 40% of total greenhouse gases, 40% of that is heating and cooling. And so it's an enormous part of the global greenhouse gas impact. And so, and to your point about the curtains and whatnot, I would like to say to people, get over it, because it's now more essential than it was in the 70s, because you know, we now see what it's doing. But you're right, but we now have systems that will help it, can make it easier. Anyway, but so
Well, before Ronald Reagan in the 70s and living in Eugene, Oregon, there were a lot of people who were quite willing to do these things. So we had a heyday, you know, developing projects that, you know, were very innovative and a lot of fun to build and a lot of fun to design with clients and that sort of thing. Yeah, it was just like a crushing blow when Reagan pulled the solar panels off of the White House about 1980, whenever that was.
yeah,
That was a crushing blow.
I think I think it's Reagan's first act as president is he reversed Carter's presidential order, which was that stores could not have the thermometer lower than like 82 degrees. And Reagan said, "No, we're Americans. You can have your stores as cold as you want." I think that was his first official act. And that's so to me that's part of what embodies the Reagan energy policy, and which has been sort of part of our world since then. Anyway, so Ani, I put my email and address in the chat.
Oh, thank you.
And if you want, I could send you PowerPoints and so Robert, this is, you know, it says a builder. So Don's process of the way he orders it is that he has quite a very unique process, and he's the only freaking person doing it in America. And
So
Yeah.
far.
I will send you. I have the email address in a notepad here, and I will send you my email so that you can send that to me.
So one of the things about maybe a couple of things on a, you know, just as the kind of the if I were to build a house for you, if I build a wood house for you, I'd say it's probably gonna, if you work really hard, you're gonna get it to, it's gonna be around for 70, 75 years. But I can build you a house out of steel, and you could really get 50 years of maintenance-free living because it's so durable. And the house is probably going to be around for a couple hundred years because the steel is guaranteed for 250 years. And that's actually, so even if it was, and I don't think it's true, even if the carbon footprint of steel is more, you're going to get more years out of it.
Yeah.
And it's not going to burn. But so anyways, the steel is termite resistant. There's no termite, there's no mold. I could go on and on.
And it's quicker to put together. That's the other thing
Yeah.
that you mentioned.
So what I would say is, so Dawn's process. So normally building with light gauge steel it has a 10 to 15% premium versus wood. So Dawn's process is got that equal.
Oh, really?
Oh,
And or less.
I appreciate you educating me because I didn't know any of that. That's interesting.
Yeah.
Well, you're smarter than most architects because
I always use the excuse that I couldn't find crews that are, fluent, you might say, in using
That's an issue.
light metal
it's
framing are rare.
It's so
Yeah.
Dawn's process. One of the things about it is it takes the part that's different out of it, and that if you can, it can actually, each piece is labeled, and so he has like there's a kit, and
That's
so the framers don't need to know, is that an 18 gauge thing or 16 gauge thing. It's labeled like this is stud 1, wall 2, or whatever it is.
that's really helpful.
I've just been finishing a 600 square foot ADU in Los Angeles, and I had prices for when we were going to build it with wood versus with prices with Dawn steel and the labor to assemble it. Pretty much the same, but then there's other savings, like the contractor who's never built with steel before but did a great job. He saved $4,000 on the cost of hauling the lumber away, the lumber waste.
Yeah.
I'd like to ask Kathryn what your understanding is of this and how, yeah, what your understanding is of this and what you have to say about it.
Well, I think what Carl is talking about in terms of doing with steel is really rethinking some of the things that we have just assumed for so long. We're really better understanding what it means to be truly regenerative. And in many cases, it's looking at really different things. There's a guy in town, and I'm going to talk to him about maybe sponsoring Soilwise, because his concern with forests and his understanding of wood really informed his new job as a winemaker. And a lot of wine and spirits are put in oak barrels, and they're white oak barrels, and the only white oak left is in old growth forests. And you can only use like 12 feet of the tree, and the trees are like 40 feet tall. And you can only use those barrels for so long, and you don't use all the wood in the barrel, only a few inches of the inside, and there's all this waste. And so he's created a flavoring agent that was distilled from wood, from white oak, that adds the same kinds of flavors to spirits and wines that they would get in the oak barrel. So you add a drop or two and it totally changes. And so he's trying to shift the alcohol industry away from barrels and into using these kind of flavonoids. So it's really rethinking things. I mean, I think we're in that phase where we have to kind of do that, because the way we've depended on nature before does not work at the scales we're requiring. It just simply doesn't. It's a slower process. Nature does not replicate herself fast enough for the 8 billion, 9 billion, 10 billion, 12 billion people that we're going to have on the planet. It just doesn't. And so we have to come up with alternatives. And we're loath to lose our lifestyles. We really want to keep the things we've achieved. And so we have to, if we want to do that, we're going to have to figure out how to do it in a way that doesn't impact nature in the same way that we have impacted it before. So I welcome these experiments, because we're just experimenting. We have no idea where it's going to go in the future, but we do have to do something different. And understanding that we can, again, is another place for our agency, another way for us to do something different. And hopefully we'll realize we don't need as much, we don't have to have a new house every year or a new car every year or those kinds of things. We can slow our consumption down, but we can also change how we consume. So that would be what I say. And I'm going to leave, and Ani, you are host. So if you would just turn this off.
Turn what off?
We'll just close the room at the end of the conversation.
Oh.
You can just do that.
Sure.
And I will talk to Carl at 12:30 and see the rest of you later.
So is there a theme you would like us to focus
No,
on?
just go ahead. We're doing fine.
Okay.
Bye, Kathryn. Now I'm getting so good at putting PDFs into the chat. I added a 1-page summary of Dawn's process, that has pictures of that you can see the information about the amount of waste, the savings of the waste savings, and also, but there's anyways, but and maybe in closing, kind of big picture stuff. One is that the production of steel is getting more energy efficient, which is good. It's not like the old factories where big pots of molten steel. But also, to this question of, and I can get ornery about this, but every damn green architect will tell you that wood is better because it sequesters carbon. But I could be a timber expert, but I'm not. But I've read a few. Most of the articles I read about that quantifying explaining the carbon sequestration benefits of wood. I've read 3 or 4 of them that they say, so they talk about the amount of carbon a tree can sequester at, an 80-year-old tree, or they present it as if the trees are being cut down for lumber when they're 80 years old, which is, can I say, bullshit?
Hmm.
You can Google this, like you just Google, how old are trees, the typical trees cut down for lumber, how old are they? And it's 25 to 40 years. And an 80-year-old tree is sequestering, at 80 years, 50 years, they're just getting started because, a bigger tree sequesters more carbon. So just on the surface of it, this idea that, the values that they're telling us about how much CO2 trees are sequestering, it's not true. It's because it's based on bad information.
So how much are the trees sequestering?
Well, I don't know. Like, so when a tree is cut down at 25 years, if you look at a chart on like how much carbon the tree sequesters, it's at a geometric progression. It goes up. So a 25-year-old tree is for each year sequesters 10%, a very small percentage compared to an 80-year-old tree. Mm-hmm. But again, the old forest, which again we don't have, and it just not from Robert, you talked about from the 70s. Most of the framing lumber through the 80s was old growth wood, which is just an ecological travesty.
Mhm.
Because so the and again, so the way a natural forest works with the biotic pump and just the soil health and all the other the habitat that it creates for so many other species. That's we should have more of that, and that's not the the tree farms that our lumber industry wants you to think as a forest. It's not functioning like a forest. It's just a monocrop tree farm.
So, Robert, I'd be interested in whatever questions you might have or responses you might have to the discussion.
Well, I mean, I'm pretty much retired now, Carl, as you might expect. I grew up in houses, one of which was 270, is now 275 years old, and the other one 200 years old. And we were sold a bill of goods. We were told, oh, how fantastic this wood, this wood is, and so forth. Well, which is true. And the siding, the split siding, which was, they used white pine because there was nothing under it. It was a frame, it was a braced frame structure for the house, not studs with plywood on it. So let me tell you something, those houses were cold because there was nothing to stop the wind. But 200 years later, the siding was all fine.
Yeah.
And it's white pine. I mean, you don't use white pine over plywood because it will rot right away within a few years.
The ventilation is part of that, but it's also there's just the quality.
Yeah.
This is this is a story that also I think explains the difference. So just after high school, I was working for a contractor in Northern California, and we were restoring an old farmhouse that was built in the middle 1800s. It was an old Victorian house, and we actually stripped all the plaster from, I guess, from the inside. And we started realizing, and I was before our college and stuff, but we started realizing that we didn't see any knots. And so we actually went, and then the floor joists, because it was a 2-story house, were like 2 inches by 12 inches. I mean, the 2 inch by, the solid, the full dimensional stuff versus today, that doesn't really mean very much, but it was big pieces of wood. And so these floor joists were, I think, 30 feet long, which you can't do that now. I mean, you can get it, but I mean, so we actually went through that house and we couldn't find one knot in all of that lumber. And Robert's like,
that makes a big difference, doesn't it?
And then that's the part that's different now, because so the knots make lumber what's called dimensional stability. It makes it expand and contract and split more.
Yeah. And it's interesting to talk to a building inspector. There are some inspectors, particularly in Vermont, where I was doing old houses, who would just, jump with glee when they saw, all this old lumber. And others who would just stop and say, there's no grade mark on this lumber. You're going to have to replace it.
From the existing?
When it was something that we'd torn apart, yes. We couldn't reuse those pieces. So there's just a lot of misinformation amongst even the professional public.
Yeah.
Those who should know, who should have spent some time investigating these things. but evidently haven't. They're just going by the rule book.
This is actually we're you and I are talking like old like builder kind of guys, but the on another thing with wood, like if you were to tear down an old house and you wanted to reuse that wood, the code doesn't let you.
Oh, I mean, some inspectors would welcome it.
Well,
They-
but
say,
but
no
per the
problem.
but per the code, you're not allowed to.
Yeah, I mean, the
But it's
code,
also you know it's pretty hard to take a wood house apart because you have to remove the nails. It's just a lot of labor. And I know from a couple of projects in Southern California there's a kind of a nonprofit that instead of demolishing a house with a bulldozer, they deconstruct it and they ship the lumber to Mexico because in Mexico they can use it and it's used for building like churches build houses for people in Mexico. And that's about the only way lumber is used from an older house, reused.
Interesting.
But it's still, but the code allows you could take that a steel house apart. Not there's a lot of them anyways, but you could take a steel house apart and reuse it because there's no degradation of the material.
you mean they aren't concerned about all those screw holes that have been put in the flanges?
Yeah.
I'm being facetious.
I know you are. Hey, I love this is the stuff I love to talk about, and if you're I have my a PowerPoint that I did years ago that's kind of an introduction that includes like energy efficient building with solar orientation and also what I call resilient building with steel, and it gives you more information about the steel. But this insight that I started with Kathryn, where I'm realizing that like this idea that we think we're building with natural stuff, and we're not. We're building with single crop, harvested wood that's not doing any. That's just terrible for the larger ecological systems.
Yeah, I'm glad you brought that up at the very beginning because that's not a factor that I see that clearly, I think. And
It's
really is elemental, isn't it?
It is. It's I've been doing I've been noodling on these questions a while now for a long time, and it's a recent insight that the light like oh my god.
Say it again.
So the way I try to think about it, and I'm just starting to articulate this. So like we all know from our trying to buy eat organic food or higher quality food, we understand that monocropping, like for food production, there's lots of problems with it. There's more pests. It doesn't build the soil. This new relatively new insight, as I now realize, is that the place that we get our lumber from, like Weyerhaeuser can send you a photograph. Here's a picture of our forest of 10,000 acres, 20,000 acres, and it looks like a forest, right? Because there's trees, but it's not a forest. It's not a forest that's operating like a forest. It's just that it's a single crop. It's a monocrop farm. Which means it's doing nothing to build the soil. There's no opportunity for the raccoons and all the other species to create a habitat that makes nature work. It's just hard earth, dirt, and trees are growing in it. And so back to this idea of the biotic pump. It's not contributing to the larger water cycle.
I know that fundamentally, I've learned that nature works best with diversity.
That's the principle.
Right. So lumber, so trees, I I don't know the terms, but where you have a monocrop of a tree forest or whatever, you have to mix it up with, you have to have more than one species of something, right? To,
But but that's not how lumber, the lumber we get is huge production. They don't do that. They're maximizing the number of trees. And so the way the primary design goal, if you will, of these tree farms, I'm going to call it a tree farm, is that they're and this is I think the single greatest reason why the lumber is such bad quality is they plant them really far apart so they get more sun so they grow faster, which I think is the single biggest reason why the lumber quality is so bad.
because they plant them how again?
They plant them far apart,
Far apart.
further apart. They grow further apart than they would in a natural forest, and so they can grow faster. And the growing faster is why, like in that picture, why the grain is so thick, so wide. If you see that picture, like the 2018 stud, it's so you can see how it's less dense. There's all the rings, like the tree rings. You see that picture?
Yeah.
Because the rings are so far apart, the fiber in between those rings, it's more like a sponge than hardwood, and so it absorbs more water. It expands and contracts throughout the year. So it's like a 3-story apartment building but now they're 4-story, 5-story building. Just a 3-story building built with our new lumber. It shrinks and expands like 1.5 inches every year throughout the year, which cracks the waterproofing membrane, which allows more water in. And this is how the buildings degrade and why they're not going to last 75 years.
Wow.
Do I know what I'm talking?
So what's the ideal way, the proper way, the most regenerative way?
I think building with steel, because it's more durable. It's non-combustible.
But I guess I'm stuck on the value of biodegradability of whatever we work with, and steel is not biodegradable.
I would say I don't want my house to be biodegradable. I want the stuff my house is built out of to resist fire more, to resist mold more, to resist termites more, so we don't have to keep rebuilding it.
I understand that and can appreciate that. My frame of reference is nature. So
maybe try to do it this way, and I may be called to another call. So it maybe has it's sort of the question is it's a bit more than just like what's it biodegradable, not bio. It's about like the larger systems, I think, and um 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 and I think making buildings that last longer and more durable in the long run is how we make our cities, our buildings that have less impact on the carbon footprint.
Okay.
And back to and I would also love to talk about passive solar. So there is within when you talk about greenhouse, the embodied carbon or the energy, there's kind of 2 parts of with buildings. So what's called the embodied carbon, which is the materials that go into the building, and then there's operational carbon, which is the energy that takes to provide thermal comfort and right. And so even if if you're using steel to build something, so the embodied carbon, the stuff that goes into the building, which is the issue of whether it's wood or steel, it's between 5 and 20% of the total carbon footprint of the building over the life of the building, because the energy that we use to make the building comfortable is the largest part of the greenhouse gas impact of that building over the life of the building. So this is why it gets, for me, this is why the building energy efficient, the solar oriented design is most important, because it's the way you reduce the carbon footprint impact of a building much more than whatever you put in, whatever the building is made out of. Does that make sense?
Yeah, I can tell it's logical, but I need to hear it again to understand.
So if you think about you think about the whole building over the life of the building, and I'll tell you, if you build the lumber today, it's going to last 75 years with a lot more maintenance, more paint, more poisons and stuff to keep it going. Versus the steel, I can build you a house with steel and the right materials that you won't have to do a thing to it for 50 years. And the things you have to do to it, like the painting and all that, that's products that are manufactured, that's stuff extracted, that's, you know, sometimes toxic paints and stuff. So there's all that, all that stuff that you have to go and put into a building to make it last, you don't have to do that. So there's a saving. But so if you think about the whole building over the life of the building, right? And you think of it as a pie, like a pie chart. The carbon footprint of the stuff that goes into the building, whether it's steel or lumber or whatever it is, it's between, some people say it's only 5% of the total carbon footprint of the building over the lifespan, because the biggest part over the life of the building is the energy that goes into making the building comfortable, the thermal heating and cooling. And so for me, so that's why the passive solar is so important, because it deals with the largest part of the greenhouse gas impact of the building.
So, Mark, do you have any questions or insights you'd like to share?
Yeah, that's right.
I mean, I'm pretty much fully aligned with what the conversation is. I think one thing that is like important to note is that when we build something as humans, we've got two options that are smart. One is we make them 100% biodegradable. And number two, we make them 100% not biodegradable. Anything in between is really dumb because it just doesn't work. It requires more resources, more effort. It's worse for the environment, et cetera, et cetera, et cetera. And so like, you know, Carl's going with the 100% not biodegradable approach. So therefore we aren't in the middle and doing dumb stuff in terms of more resources, more energy, more, et cetera, during the life of a building. And ideally, when we make it not biodegradable, if for some reason it does end its life, let's make sure it's not toxic when it gets recomposed into some other form. If we were to go 100% biodegradable, we're essentially living in grass huts. And that's a totally fine approach in the right environment, but it's not something that's particularly desirable by your modern, you know, American person at the moment.
Yeah, I think you're absolutely right. And it's a really great way of phrasing it. I think it's really the biodegradable versus, those are the two. And I really like the way you articulate that, because that's.
Yeah, and if I was to say something more, I mean, I think there is like this larger question in terms of, you know, how humans are going to live on the planet for a long time. And what we know for sure is if we are living for a long time, we'll have some type of shelter. We also have other constraints in play, which is we have very real energy limitations. At the moment, we have access to reasonably widely available energy, both in solid form, liquid form, etc., and we can use a lot of it right now. That's going to change reasonably quickly. So that's to say that if we know we're going to have housing requirements in the future, and we know that we're going to have energy constraints in the future, it does make a really strong case that what we do for housing using energy that we do have make sure that it doesn't need it in the future. And know that we won't be able to have, we'll probably have to have different types of housing when our readily available energy runs out. So it's kind of a case of like, this might be the best thing for the moment and it gives us a long runway, but knowing that in the future we might not be able to do it forever.
If I'm sorry, I keep um, those are really great. I think that I completely agree with you. When from my thinking and talking about passive solar design, and I will wrestle you with whether I think that's the right way to do things, because what you're doing is, just on the heating side of it, you're collecting the sun each day to keep you warm at night. So there's not, it's like living off the interest, not the capital. So it's absolutely the most energy efficient, and I could show you examples of the buildings that do this. They're much more efficient. But the way to think it, so what I realize is, if you design a passive solar building, what you're doing is you're using this, and these buildings don't cost any more to build, because you're not buying more expensive machines. You're building with the same kind of studs, whether they're wood or steel. You're using more or less the same windows. It's the same kind of things we've always been built with, but you build it in a way so that the envelope, it's not just a dumb envelope that you put a machine in to provide thermal comfort, but the envelope itself is part of the energy system. So it's kind of, another way to say this. So if we're going to put resources into the building, let's configure them so that they're collecting the energy that comes to the site each day, or can also be used for cooling the building. Because if in some climates, you can cool the building as well. So I don't know if this makes sense. This is so this is what for me is like another kind of exciting part about solar oriented design is you're making the building part. It's not just it's an energy system, and for me that's you're getting more bang for the buck for the resources you put into it. So the concrete slab that you use to absorb heat, it's not just a structural thing, but it's part of, it's absorbing heat energy in the winter and keeping the house warm at night, or it helps cool the building at night. So it's yes, there's a carbon footprint for concrete, which is getting better, but that concrete is offsetting, the carbon footprint of that concrete is offsetting the carbon footprint of the heating and cooling that's used if you don't take advantage of that concrete, for example. That's another incident. So just adding to what you're.
Thank you for that. I mean,
and to your point about the longevity, so that building, regardless of what happens with the energy in the future, that building is going to continue to provide thermal comfort regardless of what happens. And I keep, so one of my favorite examples of natural systems and how resilient they are is, again, looking at ancient history. So one of my favorite things they're called Persian wind cooling towers. So the Persians,
Would you repeat that phrase?
Persian wind cooling towers.
Persian what?
Wind cooling towers.
Persian wind cooling towers.
I'll put this in so you can Google that and you click pictures and you see it's very clear how they work and why they work. And so the Persians were building these, and they made ice in the desert 2,000 years ago, but that's a whole other story. But they were building these to help cool the buildings 3,000 years ago. And what we know, and that some of the oldest ones that are still around are 600 to 800 years old. And without any power, to Mark's point, without any power, like no power, there's no fans. They reduce the air temperature inside the houses in a hot part of Iran now by 12 degrees centigrade, which is impressive. And those wind cooling towers, the ones that are 800 years old, they have not been repaired once. no freon had to be recharged, zero maintenance, zero nothing for 600 years or 800 years. So that's to me is an example of that's dependable.
Well,
Just to Mark's point about how to plan for the future.
so why don't we not, why isn't that our standard practice now?
Have you heard Arnie of this little thing called capitalism?
Oh,
But Carl, what I sort of just wanted to come back with a little bit is like and sort of thanking you for expanding into the operational energy costs of a building. My comment about energy in the future was more that we won't have the energy to build structures in this way in the future. And so it's kind of like using the available upfront energy availability to build appropriate buildings that we can build now, knowing that the building types we'll be able to build in the future will be different, but so will our population. So hopefully we
Yeah.
get all of that building stock in place, and we don't need to build any buildings for a while.
That's a whole other, yeah, it's
how are you defining energy besides the sun and interaction in the soil? Might sound like a stupid question, but it's the best I can come up.
boy, I'm sorry. I put a something else in the chat. If you Google village homes, America's Forgotten Food Forest, and you're going to get an article about a really amazing development in Davis, California, which was built in 1975, started construction in 1975, and it's I think it's some people think like some permaculture gurus think it's the greenest development in the world, but it certainly performs really well. But the fact that it's 50 years old, it shows how these principles are resilient. And so I kind of think this answers some of your questions. So what they've done, they've done really well. I think the first principles of regenerative design, which is how does the water and the sun move across the site. So they designed the street pattern so that the houses can collect heat in the winter, and the houses are designed to cool in the winter or cool in the summer. But they've designed the overall plan to collect stormwater. And this is in 75 when they that was not the way we designed. It wasn't until 2010 in California that it was required. And so this is something Kathryn and I talk about. So that because they've been collecting stormwater for now 50 years, you have this really deep, rich ball of moist soil.
Mm.
So Village Homes I think it demonstrates that holistic kind of thinking, like building and also soil and trees. And again, thanks for letting me sort of branch here. So one of my mottos is building with nature is always cheaper, more efficient, and more resilient.
Mm-hmm.
And so because they worked with nature, one of the things that the developers were able to not have to put it into the infrastructure is there are no concrete drain pipes underground. And concrete drain pipes that's everywhere, right? And so this is what's really beautiful. I love this. So they saved $200,000 because they didn't have to buy concrete drain pipes. Plus there was cost to install them and all that stuff. And what they did is they bought 300 fruit trees. So to me, this is a really great example of what we're talking about. So if you work with nature, you buy 300 fruit trees, and if you build with the way we always build, you buy $200,000 worth of concrete drain pipes. Isn't it? It's beautifully simple. So what the trees have done, and they designed so they collect they're using the water's not wasted that goes into making the trees grow and it's the article I sent you. There's two videos, one from 91 and one from 2013, and there's some great stories about it. So the houses they've over the now 50 years, they've used less, at least half the energy the other houses of that vintage have used. So they've built up this reserve, this huge savings of energy and whatever. But what's really amazing is, and if you know where Davis, California is, it's a hot part of California. I grew up very close to it. It's like lots of days over 105 degrees. It's very close to Sacramento. So there are people who live there today who still don't use air conditioning through the summer.
Really?
So and this is so that ball, and this is where Kathryn and I really started clicking with. So the ambient temperature in this 60-acre development is reported to be 10 to 15 degrees cooler than the ambient temperature through the Sacramento Valley. So instead of 105 degrees, it's 90 degrees, for example. You combine that with the houses are designed to cool themselves off at night, and you have people who can get through the summer without air conditioning.
Wow.
And that to me is that's how to do it.
And that requires what? What makes that possible? What?
Nature. It's just so they designed the landscape to collect direct the water, the rain when it rains to the trees, and they've created these, like, now we call them swells, but they've created, they designed the landscape to hold the water so it penetrates down into the ground, and that's why. So in this one of the videos in that article is from a permaculture guy from Australia, and he says that probably within the first year, by collecting the water like that, the ground is more moist 3 feet down. By the third year, there's more moisture 18 feet down into the ground. So now after 50 years, you can just imagine the health of the soil, all the microbiotic or microbials, 50 years of really healthy soil.
Wow.
And that to me is what, to me, this is a really small example of what's possible. But what Kathryn and I are talking about is that we really can build communities that can cool our cities.
And so Mark, how does this relate to the principle of capitalism, which isn't environmentally friendly? I mean, capitalism isn't, it's about making money, not doing healthy stuff. What would you say about that?
I think exactly. It's simply a different motivation around what we're doing than in capitalism to what we're doing if we're trying to live well. It's reasonably basic.
Yeah, the sad news about village homes, and there's some really great white papers, academic papers written about it and how successful it is, but they all end with, why aren't there more of them? And it's what you just said. It's the but and this is what I'm trying to do. This is how I try to shape this so this is part of my profession, has got people thinking, green is good, but if you want to be green and sustainable, you have to be prepared to spend more money. So village homes would cost less to build because the way because they work with nature, there's no concrete drain pipes, there's less stuff they have to do. So, but that's kind of what Kathryn and I are working with. Like, let's flip the conversation that we really can build sustainable for the same cost or less from the initial cost. But then we also want to say that over the life of the project, you're saving a huge amount of energy and money. And that's kind of where the conversation needs to be directed to is find examples that we can build better for less, both less initially and less overall over the long term.
Are you part of a movement to see that happen? And what might that movement be called, and how can we support it?
Mark.
I mean, how can I
We're
satisfy?
we're the movement, and you know we need to grow it.
How can I help? How can we help? How can people watching this video help? Support what you're saying, the direction you're guiding us.
Well, you know, I'm really good at a lot of technical stuff, but I suck at telling stories. I'm getting better, Mark. But you know, it takes a village. But it's like you know, it's just telling the story better.
Give me the principles.
Well, maybe I think so. My mantra is building with nature is always cheaper, more efficient, and more resilient. And so, village homes is such a powerful example, is because it costs less to build because they didn't buy concrete drain pipes; they bought fruit trees. There's other reasons. Other things I could add. I could expand on that. So it's cheaper to build. It's more efficient. So now their homes they're not using, you know, they use less energy because they're heating and cooling themselves without any input. So the cost of the homes themselves is less. Some people, you know, you've read that, you know, there's some people who get 70% of their groceries, their food, from their vegetable garden and the trees, the communal fruit trees. So the cost of living is less. And so the resilient part is it's clearly more resilient. It's you know that you know, even if we had a collapse today, you know, those homes would be more, that community is more, can depend on the trees continue to grow fruit. It's going to be cooler without any energy because it's proven to do that. And so so the village home to me is a really powerful example of what's possible. And I've made presentation about this. It was cheaper to build, not more to build. And the cost of operational cost is less. And you know, because they don't have any concrete drain pipes underground, after 50 years, they've not had to repair any of them because they're not there. Much like the wind cooling towers in Persia. Give me another one. Tell me one thing that we do today that doesn't need a maintenance guide for 600 years.
Cool. So no concrete drain pipes under the surface. Don't do concrete drain pipes.
Well, that's if you work. What I was saying is that if you work with nature,
right.
You can avoid them. And I have there's a couple of projects. There's another project in Claremont where I live, that use the same principles. And so these are two projects in California, one built in 75, one in the 80s, that they use the same principles and get some of the same results. And, you know, so there's no concrete drain pipes. There's more water under the ground. Both were cheaper to build because you know it's you know and the other part of that is you work with the natural slope. Again, what's there, not so they probably save $1 million in grading, you know.
Yeah.
So nature is always cheaper, more efficient, and more resilient.
So no concrete drain pipes.
That's not a principle, that's a result.
Yeah, I was going to say, Annie, there are many local opportunities that will pop up. They'll be different in every biome, in every city even, because the conditions are different. But that's one that happened to work for this community. it's not going to be a, across the board requirement. And, you could put them in if it's absolutely required by the building department, and, which it is.
Well, it's getting
But-
less like that.
Yeah.
I'm going to
they're
push back a little bit.
open.
And this has been included in my presentation where I show that if you work with nature, the natural slope, and you do certain things, then you can avoid them. But if we don't, normally, when cities and developments are laid out, they ignore the local grading and they design like a carpet design. And so on a spectrum, the more that you design by imposing the geometry over the nature, the more concrete drain pipes or more infrastructure you'll require. And so what's critical? So this is the universal thing. If you work with nature more, you'll need less infrastructure.
Sure.
And my preferred example is that, if you've ever seen the original plan for Epcot Center, Disney's, what's now was it Disney World? Originally he had planned this, a city of the future, and it's sort of what's called a radial plan, like a star-shaped plan. To me, that's an example. That's like the best or worst example of when you impose geometry onto the landscape without thinking about nature, which is what architects do all the time. So the more you do that, the more concrete drain pipes you're gonna have. Now I have some. The more we impose ourselves on nature, the more infrastructure is required. More energy it takes to heat and cool it, the more cost is to build it.
So this has been a wonderful conversation. I'm going to have to leave.
Yeah.
I have no idea what time it is. Is it time?
I have to take a bio
It is
break.
time.
It's been great to meet you. Mark, I'd like to learn more about what you're doing, and thank you for letting me rant. And Ani, happy to send you some PowerPoints that explain some of these things in more detail and some pictures. And
I've got your email, so I will send you mine with an invitation to send me whatever you have. I really appreciate you being on this call and what you've shared.
Well, thank you. It's it's a movement. So Mark, wait. So where are you? Where are you all located, Mark?
Where am I?
Yeah, where are you located?
Yeah, I'm in Boston now. I was in Rhode Island. Yeah, when we last spoke.
Yeah, and Robert, I know you're in Oregon.
No, Atlanta at this point.
Oh, and Ani, where are you?
I'm in Santa Barbara, California.
Oh, heaven.
Heaven, it is.
Anyway,
Thank
it's
you.
been wonderful. Talk to you again.
Have a great
Even
weekend.
next-
I look forward to hearing this all again. And
Oh, it was lovely to meet you. Thank you, and I appreciate all your insights. And Mark will happy to share more. Like you get more. I really appreciated all your insights about some of these points, and
yeah,
you keep refining helps refine the message. That's the teamwork part.
all
Yeah.
right.
Great.
Bye.
Take care.
Bye-bye.